Hey guys, welcome back to part 2. Sorry, the last video got cut off, so I'm gonna reiterate this part as a part 2 of the video. So the tangent of a graph of the function y equals to px squared plus 4x minus 5 at the point where x equals to 3 passes through the point 0, 4. Find the value of p and hence the equation of the tangent. Alright, so our first step is to differentiate our function because we want to find the tangent. Okay, so our final step is to find out y equals to mx plus c. So what is our tangent line? So dy over dx that equals to 2px plus 4. Okay, so if we substitute our x equals to 3, that will find our gradient at the point. So therefore we can find our gradient. So dy equals to dx equals to 6p plus 4. So now we can rewrite our tangent line equation as y equals to 6p plus 4 multiplied by x plus of c. Alright, so it also passes through the point 0, 4. So therefore, if we substitute our x equals to 0, we'll get y equals to 4. So 4 equals to 6p plus 4 times of 0 plus c. So therefore, 4 equals to 0 plus c, and therefore our c value is actually equal to 4. So y equals to 6p plus 4 times of x plus 4. Alright, so now we need to find exactly what is our p value, okay? And to do this, we need to find actually we don't need to find, okay? We need to equate so the tangent touches our function, so therefore these 2 points are equal at x equals to 3. So we can say that 6p plus 4 of x plus 4 equals to px squared plus 4x minus 5. So when x equals to 3, these two are equal. So we're going to substitute our x equals to 3. So therefore 18p plus 12 plus 4 equals to 9p plus 4 plus 12 minus 5. So 12 and 12 cancel. If I move the 9p over, it'll become 9p on this side equals to negative 9. So therefore p we can figure out as negative 1. And now we can rewrite our tangent line equation. So therefore y equals to 6 times of negative 1 is negative 6. And therefore, negative 6 plus 4, that's negative 2x plus 4. And that is our final answer. And that will get you your excellence grade. To get a merit grade, you're looking at the correct value of p found. So finding p equals to negative 1 will get you a merit grade. And to get an achieved grade, you're finding the expression when x equals to 3. So 6p plus 4, that will get you an achieved. Alright. Question 3. Find the x-coordinate of a point of the graph of the function f of x equals to 4x minus x squared, where the gradient is equal to 10. So therefore, we need to find what is the x point when the gradient is equal to 10. And we can do that by finding our derivative. So f dash of x equals to 4 minus 2x. And when the gradient is equal to 10, so substitute our gradient equals to 10, that equals to 4 minus 2x. 6 equals to negative 2x, therefore x equals to negative 3. And that is our easy achieved grade there. Swimming pool is being filled. At the deepest point, the depth of the water in the pool at any instant is h meters. The volume of the water in the pool, v meters cubed, is given by v of h equals to 20h squared plus 40h. Find the rate at which the volume of the water is changing with respect to the depth when the water of the pool is 0.5 meters deep. Alright. It's at the deepest point. The depth of the water is h, okay? Find the rate at which the volume of water is changing when the depth of the water in the pool is 0.75. So we need to find our dv over dh, and that will be 40h plus 40. So what is the rate changing when the height is 0.75? So we just substitute our height as 0.75 plus of 40, and that should give you 70. The unit is, so the volume is changing with respect to the depth. So meters squared per meter. And that's going to get you achieved. A balloon is being inflated with helium. The volume v centimeters cubed of helium in the ball is given by v equals to 4 over 3 pi cubed, where r centimeters is the radius of the balloon. Find the rate at which the volume of gas in the balloon is changing with respect to the radius, and the volume is 288 pi centimeters cubed. So we need to find what is the radius when the volume is 288 pi centimeters cubed. And then we substitute that radius into the derivative to find what is the rate of volume that is changing at that time. So we can say that 288 equals to 4 over 3 pi r cubed. If we do a little bit of math over here, get a calculator out, 288 divided by 4 over 3, that gives us 206. That gives us 216 equals to pi r cubed. And therefore, if we divide 216 by pi, and we find the third. So it's 216 equals to r cubed. So third root of 216, and that's divided by pi. Divided by pi. And if we plug that into our calculator, sort of way to do this on this. To the power of 1. Sorry, just calculator issues on my computer. Find the third root of that. That should give us 4 point r equals to 4 point, which is rounded to 4.1. Okay, so now we need to find out dv over dr. dv over dr equals to 4 times 3 is 12, 12 over 3 is 4, so 4 pi r squared. So now let's substitute r is 4.1. So dv over dr equals to 4 pi r is 4.1 squared. We get our calculator. The squared times of 4 pi. That should give us our answer. Sorry. And that should give us our answer. So 4 pi r right. I keep making these silly mistakes. Sorry guys. Far out. Having a terrible day today. I missed a really key information. So it's actually 288 pi. Okay, so that equals to 4 over 3 what was that, pi cubed. Sorry again guys, I'm so turned off today. So 216 equals to, that makes a lot more sense. So r equals to 6. So now we found out dv equals to dr over dr, and that gives us 4 pi r squared. dv over dr equals to 4 pi 36, and that makes life a lot easier. That is just simply 56 times 4. That just simply gives us 144 pi centimeters. Is this centimeters? Yep, centimeters cubed per centimeter. And that should give us some grade. Okay, to get an achieved grade, you're finding that derivative found is set to 0. So so correct equation. Okay, so just using this equation here is enough evidence for an achieved. Alright, yeah, apologize again for that. I keep missing really key information in the question. Sorry guys. I actually apologize. That's the third time I've messed up today. Sorry guys, I apologize once again. The length of a cuboid is 3 times its width. The sum of the height, width, and length is 150 centimeters. The volume v centimeters cubed can be expressed as v equals to 450x squared minus 12x cubed, where the width is x centimeters. Find the height of the cuboid for which the volume is a maximum. So the length of the cuboid is 3 times its width. So we can say L equals to 3x, while the width equals to x. Okay? The sum of the height, width, and depth is 150 centimeters. So 150 minus the 4x will give us the height. Our volume is expressed as WLH. So therefore, our volume can be expressed as 3x squared times of 150 minus 4x. So V can be expressed as 450x squared minus 12x cubed, which was already there. Oops. dv over no, in terms of h, so find the height of the cuboid for which the volume is the maximum. Okay. That changes things a little bit, so actually, no, it doesn't change things at all. What am I doing? So, dv over dx equals to 900x minus 36x squared. Substitute it equal to 0 because it's a maximum. That equals to 900x minus 3. Take the x out, so therefore 900 minus 36x equals to 0. So therefore, you can find out your x value. Your x value should come out as... No. Should come out as 25, okay? So x should come out as 25. And we substitute x equals to 25 into our height formula. So therefore, 150 minus 100, that equals to 50 centimeters. So there is your answer. And that will get you your merit grade. To get an achieved grade, you're looking at finding the derivative and set to 0. Alright. That's an achieved. Alright, next question. The graph of a function g of x and the graph of its gradient function are shown below. Find the value of m, the y value for the maximum turning point of the function gx. Alright, for this we have to be precise and we need to find the exact equation of our parabola. So our parabola, our vertex is at 2, negative 1. So 2, negative 1 is our vertex. So we say y equals to a x minus 2 whole squared minus 1. Now we need to find what our a value is, okay? Our a value can be found by substituting a random point on the graph, okay? So we can substitute our, substitute 0, 3. So we can say 3 equals to a 0 minus 2 whole square minus 1. 3 equals to a negative 2 squared minus 1. So 3 equals to 4a minus 1. Therefore, 4 equals to 4a, a equals to 1, okay? So therefore, our parabola is therefore is just y equals to x minus 2 squared minus 1. Alright, now we need to expand and integrate. So y equals to x squared minus 4x plus 4 minus 1. So that just becomes plus 3. And now we can integrate, okay? So now we can say if we integrate it, it will give us g of x. So g of x equal to 1/3 of x cubed minus 2x squared plus 3x plus c. Now we just need to find our c value, which we can do by substituting a random point in the graph once again. So we can substitute, looking for a point to substitute, so can substitute 0, 0, should be able to. No, probably not best to not substitute 0, 0. Okay, we can substitute this point, okay, that's 0.2. Actually, we can't do that. We can substitute, or we can choose, we can substitute x equals to 3 and y equals to 0. We can try that. X equals to 3 and y equals to 0. So 0 equals to 1/3 of 3 cubed minus 2 3 squared plus 9 plus c. So 0 equals to, that's 27, 9 minus that's 9, 18 plus 9. Yeah, plus c. So therefore our c value is also equal to 0. So g of x, now we know our g of x is 1/3 of x cubed minus 2x squared plus 3x. Now we need to find what our y value is at the maximum turning point, which is x equals to 1. So all we need to do is substitute x equals to 1. So g of 1 equals to 1/3 minus 2 plus 3. G of 1 therefore equals to, if I can simplify this, so 4 over 3 should give us, yeah, that should give us 4 over 3, and that will get you your excellence grade. To get your merit grade, you're looking at finding the g of x correctly. So finding our g of x correctly, that's this part. Getting this correct will get you a merit grade. Alright. An aircraft traveling at 70 meters per second when it lands, its speed changes at a constant rate of negative 3.3 meters per second. Use calculus to find how far the aircraft will travel from where it lands to where it has a speed of 4 meters per second. When it says its speed changes at a constant rate of negative 3.3 meters per second, that's basically saying that the acceleration is negative 3.3. We'll integrate to find out v of t. V of t equals to negative 3.3 t. An aircraft is traveling at 70 meters per second when it lands. So therefore, at the start of the journey, so when t equals to 0, we need plus c here. So when at the start of the journey, when t equals to 0, our speed was 70. So we can see that our c equals to 70. So v of t actually equals to negative 3.3 t plus 70. Use calculus to find how far the aircraft will travel from where it lands to where it has a speed of 4 meters per second. So after how long will the plane have a speed of 4 meters per second? We can substitute v equals to 4 and we can find the time. Negative 66 equals to negative 3.3 t. Should get that the time is 22. No. Sorry guys. No, it's 20. So t equals to 20 seconds. And now we need to find how far has the plane traveled in 20 seconds. So therefore, s of t will equal to negative 3.3 t squared divided by 2 plus 70t plus c. So because it says from where it lands to where it has a speed, so at the start where it lands is traveled no distance. So when t equals to 0, our distance is equal to 0. So therefore our c will be equal to 0. Now we need to find out s of 20, not s of 2, s of 20. That equals to negative 3.3, 20 squared divided by 2, plus 17 multiplied by 20. And we just need a bit of calculator work here. So 20 squared is 400 times of negative 3.3. No, not 400. That gives us divided by 2 plus 1,400. That should give us your answer as 740 meters. It should be your final answer. And getting 740 meters as your final answer should get you your excellence grade. To get a merit grade, you're finding the distance function correctly. So finding your distance function correctly is a merit grade. Well, not there actually, it's here. Finding your distance function, that's a merit grade. To get an achieved grade, you're looking at the velocity function found. So velocity function found here, that's going to get you an achieved. Alright, thank you for watching this video. I hope you enjoyed. Sorry about many stuttering and mess ups, silly, not just mess up, but really silly ones today. It won't happen again, but I apologize for that. But still, I hope you enjoyed the video, and I hope to see you all in the next one. Thank you, bye.